Hey, this is Jamie, and welcome back to our fourth analysis video for our Zappos project. In this project, we're going to be working on making correlograms. So to get started, you're going to insert another sheet. I already have one started here when I've copied in the description of what we're doing in this section. So in this section, we're going to create a correlogram in Excel that shows the correlation between each of the variables in our data set. And then we're going to insert a text box and discuss the strength of the correlation between the pairs of variables. So which variables have the strongest correlation and which have the weakest, and is there anything particularly surprising or unexpected in these relationships? So let's make that correlogram, and then we'll come back and we'll have a conversation about what we see. So to make a correlogram in Excel, the easiest way to do that is again to start by bringing over your data. We can bring over, I'm going to copy and paste all of it into what is currently my sheet 6, but what I'm going to rename A4 because it's the fourth piece of our analysis. So in this case, because we're looking at correlograms, I don't need to see the brand or the model, and I'm going to hide that to give myself a little bit more room. And then we're going to do a little bit of moving, because when we make the correlogram, the first or the leftmost variable is the one that's going to end up on the left, and that makes it the easiest to interpret. So let me explain this just really quickly. We're going to insert a column to the left. We're going to cut overall rating. We're going to paste it over here, and then we're going to delete column J. So what I'm interested in, and what maybe I should have expressed more clearly in the project description, and it will show up in your project description after this video, but what we're interested most in isn't just all variables willy-nilly, but I want to understand what of these, price, MSRP, whether or not it's on sale, the number of reviews, true to size rating, true to width, comfort rating, and style rating, which one of those are most closely associated with the overall rating for the shoe? Because here we're moving out of our discussion about brands and how they're similar or different, and we're moving into the second question, which is, well, what makes a good running shoe? Is it cheap? Is it on sale? Is it reviewed a lot? Is it high and true to size or true to width? Or maybe it's particularly comfortable or fantastically stylish. So to make our correlogram, we go into the Data tab, and there's a box that's called Data Analysis. This is a very useful box to get used to. And in this box we can do, well, in the drop-down or the pop-up box, whatever this is, we can select from a variety of different statistical tests or other things that we're interested in. And we're going to use this correlation tab. And I'm going to say OK. And it's going to pop up that it wants to know what data is going to be in our inputs. And in this case, it's offering C1 to K226. And like with our pivot tables, Excel knows. And it didn't include the hidden values, so that's perfect. And then the next thing it wants to know is, where do we want to put it? Output range, it's suggesting M3 for me. I don't know if it's suggesting M3 for you, but I want to place it in M1. The reason for that is that it'll put the headings in row 1, just like these headings here. I do have labels in my first row, and that's important to also have checked. And then I'm going to click OK. All right, let's tackle some formatting here. We'll start by taking all of these numbers and formatting them as numbers with 2 decimal places. I'm going to double click between M and N to make M wide. And then in the row, my first row here, I'm going to wrap the text, and then I can kind of close everything up in a way that gives us enough room and tidies up our spreadsheet. Number of reviews doesn't fit all the way, so I can make column 1 bigger, but now here's our correlogram. Make M and N wider again. Okay, now I'm happy. All right, so how do we interpret this? Well, so first off, there's some things that we might want to know or think about with regard to what correlations are. Correlation is one of many ways that we can measure how strongly two variables are related to one another. A correlation coefficient is going to range between -1 and +1. A correlation of either -1 or +1 tells us that the variables are perfectly related, that we can tell what one is by knowing the other because they always go together. If it's negative, as in the correlation is below 0, it means that as one value goes up, the other value tends to go down. You can think of this if any of you have chickens. The older your chickens get, as age of chicken grows, their egg laying declines. So as chicken gets older, they lay less eggs. We have a negative correlation. Something that's positively correlated, as you know from being a student or studying, is that the more you work, the higher your grades are. Those things are positively correlated. And so one thing that students always ask is, what's a good correlation coefficient? And then because you really want to know, you Google it. And the thing is that depending on the field, what makes a correlation coefficient good or strong is going to vary. And so here is kind of what I'm thinking about. In this class, we can think about correlations as being having two variables as having no relationship. And we're going to think that if it's something less in absolute value terms than 0.1. So less than 0.1. Here we've got overall rating and MSRP. They have a negative correlation, which would imply that as a shoe that's more expensive, its list priced is more expensive, it's a little bit less highly rated. That's what that would determine. But because the correlation coefficient is so small, less than 0.1 in absolute value terms, we'd say those two things are not related. Also, price, a small, very small positive correlation, which would indicate that higher shoes or higher priced shoes have higher ratings overall. But with a correlation coefficient of 0.07, that's too small for us to say there's really a relationship. We'd say there's a weak relationship if that coefficient falls between 0.1 and 0.4 on an absolute value terms. So in this case, we would have something along the lines, we could look at true to size, shoes that are rated higher as being more of them are rated as being true to size, have a higher overall rating, same with true to width. And what I would consider a moderate relationship would be something that is probably between 0.4 and 0.6, like style. And a strong relationship, I'd say it's maybe 0.6 or greater, like comfort. One of the things you might be noticing here is that on sale is got a divide by 0 error. That just is because a shoe that's on sale, that has an on sale value of 1, is always going to have an MSRP, and it's always going to have the value of 1. We can't really decide if they're correlated or not, and then there's also no real variation. So we're going to clear that out. And after this, we're going to add some conditional formatting so that we can see clearly and quickly. We're going to kind of make a heat map where our correlations are highest and where they are lowest. So on the Home tab, we have our conditional formatting, and I want to go to color scales. And we're just going to pop down to more rules. Why? Because I want to use a 3-color scale where our lowest value is going to be our minimum. It's fine if we want to leave it red. And our midpoint is going to be the number 0, because if things have a correlation coefficient of 0, it means they're not related. And we're going to color those white. And then our highest value, which in this case is all of these 1s, because everything is correlated 100% with itself. If we know price here in the row, it's 100% correlated with itself. That's why those show 1s. You kind of just ignore the 1s. They're going to end up showing up bold in our, once we make it blue, I'm going to choose a lighter blue actually. Once we add the colors to these, of course things are correlated with themselves. Since we're interested in overall rating, we're interested to see how overall rating is correlated with price, MSRP, whether or not a shoe is on sale, the number of reviews it has, true to size, true to width, and comfort rating. So here for these men's shoes, we would say that overall rating has a weak relationship with whether or not a shoe is on sale and the number of reviews. And how we would interpret this would be that if a shoe is on sale, it tends to have a lower rating. As on sale goes up, overall rating goes down. And as overall rating goes up, whether or not the shoe is on sale becomes less likely. And I can kind of relate to this from the consumer's perspective. Oftentimes when I buy something just because it's on sale, I buy it because my checking account wants me to have it and not the more expensive one. I'm often disappointed because it's not the one I would have chosen. I mean, that makes sense. Another one, number of reviews, weak relationship. Shoes that have more reviews tend to have higher overall ratings. And if you remember from before, the number of reviews is kind of our proxy for popularity. It's flawed because a new shoe could be quite popular but not reviewed much, but the shoes that have a lot of reviews tend to be the ones that have sold the most, and the ones that sell the most tend to have higher overall ratings. It's a weak relationship, but it does make sense. In our moderate relationship range, or in our moderate relationship range, we can say that we've got true to style and true to width. Shoes that customers believe are true to style and that they believe are true to width tend to have higher overall ratings. That makes sense, right? If they fit, you're likely to rate them more highly than you would if they didn't fit. And then we've got style, which has, a moderate to strong relationship with overall rating. As people think a shoe's more stylish, they're more likely to rate it high. They're more likely to give it a higher overall rating. And the strongest correlation between overall rating with overall rating is comfort. So people who rate a shoe highly for comfort also tend to rate it highly for style. If I come out over here, there's some other correlations that I think might be interesting, like this price and MSRP. So here we've got price. Price is highly correlated with MSRP. So price is the price that the shoe is on sale for, or that it's selling for. It's highly correlated with MSRP. So it's kind of like saying shoes that are cheap when they're at full price are still kind of cheap when they're on sale, or vice versa. A shoe that's really expensive is still somewhat expensive if it's on sale. And then on sale, shoes that are on sale, whether or not a shoe is on sale is negatively correlated with its price. So brands that have a lot of shoes that are on sale also tend to be lower priced shoes. It's not super strong because, as we saw in the previous chart, if we look at something like, Mizuno, for instance, its highest price shoe is very expensive, and its lowest price shoe, this one might even be on sale for $105. It's still more expensive than the average price shoes in these brands. So being on sale isn't going to make a shoe suddenly the least expensive, and you guys probably recognize that too. There's something you want, it goes on sale, but it's still too expensive. Other things that are interesting to me, I think, is that shoes that are true to width have a moderate correlation with being true to size. So brands that are sized well for length are also sized well for width. And style and comfort have a high correlation. If someone thinks a shoe's stylish, they're likely to think it's comfortable, and vice versa. So here are the notes for how I might type that out to submit it. And that's what you need to know. Knock yourself out with correlations, ask questions if you have any.